Imagine a scientist's office in the 1970s. On the table, there are stacks of papers, a calculator, a yellow lamp, and a bulky computer in the next room. Everything he does requires patience, manual calculations, and a week of experimentation. Now fast forward to 2025, the same scientist, but surrounded by artificial intelligence, quantum simulations, digital twins, and global databases. One world built science on enthusiasm and intuition, the other on data and computing. This is a story about how not only science has changed, but also the very essence of a scientist's thinking. In the 1970s, science was personal, almost romantic. Scientists lived by an idea that might seem crazy, but it was such ideas that drove progress. It was a time when discoveries were made not at the expense of computing power, but at the expense of intelligence and perseverance. Experiments were often conducted manually. The results were recorded in notebooks, and the analysis took weeks. Mistakes were part of the process, and intuition was the main tool. The scientist of the 1970s was, first of all, a researcher. He believed in the power of hypothesis and the boldness of assumptions. In those years, the computer was considered an auxiliary device rather than the main instrument of science. Most calculations were done manually or on mechanical machines. Scientific publications were printed on typewriters, and access to information was limited to libraries and personal contacts. International cooperation was rare. Knowledge exchange took place through letters, conferences, and rare joint projects. The science was slow but profound. Every experiment was thought out to the smallest detail because the resources and equipment were expensive. The scientists of the 1970s spent months, and sometimes years, on a single task, achieving accuracy and confidence in each result. This formed a special mindset, fundamental, analytical, attentive to detail. But there were limitations to this approach. Due to the lack of data and tools, many hypotheses remained unconfirmed. Scientists depended on intuition and experience, not on massive amounts of information. This made science a personal art, but slowed down its speed. Now let's take a look at 2025. A modern scientist does not work with papers and flasks, but with data clouds and neural networks. His laboratory is a supercomputer connected to millions of information sources. It can simulate processes that previously required decades of experimentation. One request to the system, and artificial intelligence produces a forecast based on billions of observations. If the scientist of the 1970s was a master of observation, then the scientist of 2025 is a data architect. Modern science has become international and interdisciplinary. Biologists collaborate with programmers, physicists with interface designers, and chemists with data analysts. The boundaries between disciplines are blurring, and artificial intelligence has become not just a tool, but a full-fledged partner in research. The scientist of 2025 is not afraid to use machine learning to find patterns that humans are unable to notice. He creates simulations instead of dozens of physical experiments. It relies on algorithms, but it doesn't lose its creativity. However, there is a profound difference in the philosophy of science between these eras. The scientist of the 1970s was a nature researcher. He was looking for answers to fundamental questions. Why is that? And how does the world work? The scientist of 2025 increasingly asks the question, how can this be applied? Modern science has become more pragmatic, closer to technology, industry, and business. This accelerated progress, but sometimes pushed aside the pure curiosity for which it all began. There is another side to the coin. In the 1970s, science was almost isolated from society. People saw the result, but not the process. Today, science has become open. Publications, databases, conferences, everything is available online. A scientist now works not alone, but in a network team where thousands of researchers can simultaneously improve one model or theory. This is the era of the collective mind. The scientist of 2025 lives in a world where quantum computing, nanotechnology, and bioengineering are changing the very nature of research. He can edit genes, model molecules, and create new materials. All this is possible thanks to the integration of artificial intelligence. Machines take over the routine, leaving man to create and interpret. But with the opportunities came responsibility. A modern scientist should think not only about the results, but also about the consequences. Issues of bioethics, AI control, and data protection are becoming part of the scientific agenda. If a scientist in the 1970s could simply search for the truth, then a scientist in 2025 should take into account the social context and the possible effect of his discoveries. Despite the difference between the epochs, they have something in common: a belief in progress and the power of knowledge. Scientists of all times are united by one idea: to understand the world in order to make it better. Only the tools and scale have changed. Previously, the main instrument was a microscope and a slide rule, but today it is cloud computing and artificial intelligence. But there is still a person behind all this: his curiosity and desire to learn. The scientist of the 1970s is a romantic of science, a man who could work at night on formulas, dreaming of a discovery. The scientist of 2025 is the pragmatist of the future, managing digital simulations and data. But both are driven by one thing: the passion for knowledge. Without the former, there would be no second. Without their experiments, hypotheses, and failures, there would be no modern progress. Today, science has become faster, more accurate, and more global. But perhaps, somewhere deep down, the scientist of 2025 still envies those who could discover an entire field of knowledge from scratch, relying only on curiosity and faith. After all, it is this faith that is the engine of progress that connects the past and the future of science.